Here's the next question, number 3. The following figure shows the connection of an ideal transformer with primary to secondary turns ratio of 1:100. The applied primary voltage is 100 volts RMS, 50 Hz AC. The RMS value of the current I in amperes is dash. Okay, so this is not a multiple choice question, so we will have to be careful in working it out. So we have been given an ideal transformer with all the ratings as you see in the figure here. So the first thing we do is to try writing or transferring the secondary parameters to the primary side. Since we are asked to find out the value of the current in the primary side, so let's shift everything to the to the primary side and then write an equivalent circuit. While doing so, we will be able to find the current, the RMS value of the current. So first, let's transfer the secondary parameters to the primary side. Now, in order to do this, we have to find out two specific values. We need the value of R1 and XC1 or XC dash. So these are the two values that we need in order to draw the equivalent circuit. Talking about secondary parameters, transferring them to the primary side. So these are the two values that we require. Now here is the formula. I'll just write that down here. R1 can be found by multiplying the given value R with the ratio of V1 by V2 square. So this is the general formula. Now if we were to substitute the values, we have R given to us as 80K, 80 into 10 power 3, and V1 is given to us as 100 volts RMS. So that's 100 divided by V2. So V2 is the voltage, the primary voltage times the number of turns that is given to us, that's 100. So the ratio is given to us as 1:100. Now this ratio should tell us what V2 is. If V1 is 100, then V2 will be 100 times 100. I'll put that down here. V1 is 100, then V2 is 100 into 100. So that's V1 into the number of turns according to the ratio given. So here we have 100 into 100 square. So let's see now 100. So that's 1 by 100 and that would give us 8 ohms. So the value of R1 here is 8 ohms. So the next thing is to find out what the reactance is. So XC dash. So let's find out what this is. We use the same formula. We have XC this time multiplied by the ratio V1 by V2 square. Now XC given to us is 40. So that's 40 into 10 power 3 into the same ratio 100 divided by 100 into 100 square. So we get here 4 ohms. So we have the values of R1 and XC dash. Now let's draw the equivalent circuit. I'll just get another sheet of paper. Right. Okay. Now here are our values. R dash or R1 is given to us, we have found it to be 8 ohms, and XC dash is 4 ohms. Okay, so now we need the equivalent circuit. So the equivalent circuit can be drawn, forgive my drawing, it's a little rough, right, that's about it. Okay, so we have the value, the RMS value given to us as 100 volts. Here we have J10 as given in the diagram here, 10. 8 ohms of what we have found, R1, this is XC dash. Now this is minus J4. Please keep that in mind, alright? It is quite important. So here for the capacitive reactance, we have it as minus J4. Now this is XL, the inductive reactance. So that would be positive. Well, whereas for capacitive reactance, it would be negative. Now, let's calculate. We need the current. Now, in general, we know what the formula for current is, right? So, current I, V by R. Our very general formula. So, let's utilize that in order to find our value. I is equal to, we have 100 divided by the sum of all of this. So, that's resistive 8 plus J10 minus 4. Now, in order to find out what the magnitude is, we find the resultant, and the resultant would be 100 divided by root of 8 square plus, here we have 10 minus 4 square, and that gives us 100 divided by root of 8 square plus 6 square. That's 100 by 10, and that gives us 10. So 10 amps is the RMS value of the current. So that's our final answer here. I hope this has helped.